Hello everyone, welcome back to the channel. I hope you guys are doing amazing. So let's see today's daily challenge on Leetcode and try to solve it together. So you are asked to find the subsequence of length k with the largest sum. So you are given an integer array nums of integer k and want a subsequence of nums of length k that has the largest sum. Return any such subsequence as an integer array of length k, and you need to uh, yeah, it's given the what is the definition of subsequence. It is given. I think you already know it. It's an array that can be derived from another array by deleting some or no elements without changing the order of the remaining elements. So you are asked to select a subsequence of length k which has the largest sum. So it is quite obvious that you have to select the k largest values, but you need to preserve the order while doing so. So let's take an example and see how will you actually solve it. So let's take something like n equals to 7 and k equals to 3. So let's say we have something like 916 uh 3 4 4 8. Okay, so we have something like this where n is 7 and k is 3. So you can easily understand that if you are asked to pick a subsequence of length k which has the largest sum, then you definitely need to pick 9 6 and 8 and return this as your answer. Because this is the top three elements, right? Because these are the three largest element in the array. So what you can do is that it's very simple. You can sort it, right? But if you try to reverse sort it, what will happen, you can visualize easily, is that if you try to reverse sort it and write it something like 986 4431, then you will end up in selecting this subsequence 986, which is different from 968, right? Which is different, although the sum is same, but this is the correct answer, this is wrong. So how will you preserve this order in the original array while also sorting it? There comes the main question, that how will you preserve the order? So what you can do is that you, instead of sorting single elements, you can sort pairs. If you don't know, sorting pairs preserves the index number also. So what do I mean by it? Let's say this has an index number of 0, 1, 2, 3, 4, 5, 6. What does sorting by pair means? Instead of taking these elements, what I will do, I will create a separate vector which will consist of pairs. Okay, so what pairs it will consist? It will have 9 comma 0. It will have the element comma the index number. Okay, then again it will have something like 1 comma 1. Then it will have something like 6 comma 2. Then it will have something like 3 3. Then let me write it quickly, 4 4. I guess you are easily understanding what do I mean by it. uh, the format which we will store this is value comma index. Okay, we'll store a we'll store a pair of vector which is of type value comma index. So what do I mean by this? When you will sort this, when you will reverse sort this, okay, you just reverse sort this using whichever language you are having. You just, whatever way you sort a normal vector, you just use the same thing. What you will get is that after reverse sorting this vector, this 2D vector kind of thing, after reverse sorting, you will get something like 9 0 will be at the first because 9 is the largest element. Then there will come 8 6. Okay. Then it will come 6 2. Okay. Then it will come something like 4 5, 4 5. Okay. Because 4 is the next largest and 5 is the among these two equal things. Uh, this is the more largest one. Okay, so that in that way the remaining portion of the array, but we are concerned only about called k equals to 3, right? We are concerned only about the case where k equals to 3. So only the top three elements we are focused about. Okay, only these top three elements since k equals to 3. So what we do is that we need to print, we cannot print this 986. Okay, our order, if you remember, it was 968. If you remember, our order was 968 because this order, this 0 comes first, then comes 2, then comes 6. So how we will take those orders? So what we do now is very simple. We will create another vector. Let's create a vector which is known as which will be known as an index. Okay, vector index. So what will I do here? I will create a 7 length vector. Okay, so 1, 2, 3, 4, 5, 6, and 7. Okay, so I have a 7 length vector whose indices are something like this. Okay, so after creating this vector, you just go through the k elements. You just go through the top k elements and just pick the pick the next index, whichever index, and mark 1. So what are the indices here? You can see 0, 6, and 2. So you go to 0, mark 1. Remaining all you initialize by default as 0. Then you go to 6, you mark 1. Then you go to 2, you mark 1. Remaining all indices will be marked by default 0. By default, you mark all of them 0. Then what you do, you just traverse this array from left to right and store your answer. Okay. As you traverse this array from left to right, you just need to store your answer as what? If it has an element 1 present at the value, then take the index. Okay. You are using a variable I to iterate. So you see that if index of I, this thing, is equals to 1, if this is 1, what do you do? You just store your vector of answer. Vector, whichever was your initial vector, yeah, I guess it was nums. Okay. So you store your, let's say, nums of 0 first. Okay. Then you will end up in storing your nums of 2 first. And then you will end up in storing your nums of 6 first. Whichever 0 to 6, I am choosing 0 to 6 because they have a particular corresponding elements, which is 1. Okay. Now you can easily see that in the original array, nums of 0 was nothing but 9. Nums of 2 was nothing but 6. Nums of 6 was nothing but 8. Okay. So if you try to see the original array, okay, 9, 1, 6, 3, 4, 4, 8. Okay. What was the 9, 1, 6, 3, 4, 4, 8? So the first element is nothing but nums of 0, which is 9. The second element was nothing but 6. And the third element, last element is sixth element, which is 8. So you see, you end up in picking this in order and you can just return this answer. Okay. You will get a very correct answer. So I guess it was simple to understand. Okay. So if you don't know this reverse sorting using pairs, this might be a little difficult to you, but you still might end up in doing something by using hash maps or maybe using priority queues. But those things are not required here, not required at all here. It's very simple, very easy. All you need to do now is implement this. So I guess you have already understood what I mean. So let's try to write the code. Let's try to write the code. So you see, I always do what? I take the n, okay, and then I go through, I just create a vector which will be storing but nothing but the vector of pairs. Okay. So I create this vector. I will do what? I will go through all the elements in nums and I will store vector dot pushback. I will do something like vector dot pushback. I will store a pair. Pair, what is the pair? It's nums of I comma I. Okay. If you see what I am storing here, you should not get confused at all because if you see what I am storing here is nothing but nums of I, which is this element comma I, which is the index. So that is what I am storing here. And you can do a reverse sort as you do in any language, right? You just reverse sort the vector. So how do you sort in C++? Vector dot, okay, R begin and vector dot R end. That's how you reverse sort a vector. So once you have reverse sorted, you just create an index array. You just create an index array. So what was this index array? As I had explained you, it was nothing but this array, which was of length n, and this is a binary array. Initialize this with 0. So by default, initialize it with 0. And you just, what you do, you just go through the first k elements and just corresponding index numbers, you just mark as 1. So first k elements I will go through. So first I will start from 0 to I less than k, I plus plus. I'm going to the first k elements and whichever is the second element, okay? Second element. So v dot I is the ith element of v. which is a pair, and v dot I of 1, v of I of 1 is the second element. Okay, we need to mark this second element index as 1. I hope you easily understood this. Okay, v of I, okay, v of I was nothing but this. Let's say we are taking 6. V of 1 is 8 comma 6. V of 1 comma 1 is nothing but this 6 value. This 6 I am marking at this index. Okay, index of that 6 is nothing but 1. Okay, so I have just marked it. Now you can keep a vector of answer very easily, and you just store all the values. You just go through the index number from 1 to n, and what you do is very simple. I just put out the wrong bracket. So answer dot push back, what you need to do now is that you just put uh, this value. Okay, if you need to check if the index is 1, then only you will push, right? So you just check if index of I is equals to 1. So you just keep it like that. If index of I, that means if 1, then what you do? Then you do answer dot back num5. Okay. So that's all you need to do if you think, and you just return answer. I think you will get all correct by doing just this. So let's see what's the result. You see we have an accepted thing. If you try to submit it, so you see we have okay runtime complexity, not that okay, but this thing I don't trust about Leetcode. Sometimes it gives very low and very high also. Many times it does give correct, it does give you correct, but I will tell you. You see, what is the time complexity of this code? It's for the sorting. For the sorting, this is n log n, right? For the sorting, it is taking O of n log n, and these things are O of n, these things are O of n. Okay, so but if you try to see, O of n log n only. Okay, plus n is there, but it's only n log n. So that's quite easy. I mean, log of base 2, if it is there, so that of 1000, it means that you have nothing but 10 into log of 1000 is nothing but close to 10 when base is 2, and you have n as 1000. So it is coming as 1e4, which is quite optimal. So it is the correct solution. You don't need to think about the percentage bit. So yeah, that's all for this solution. And I hope this was definitely an easy problem for today, and your day should also go as easy as the problem. Thank you so much.